You don't remember at all? Okay, so we'll talk about list. Okay, and list is like vector. Only difference is it can hold data from multiple data types. Okay, so in vector, all the data has to be of same type. Okay, all the data, all the members of vector have to be of same type. But in list, okay, they can belong to different data types. Okay, so if I create a list, okay, and let's say I need to call list function, and here I pass, let's say, apple. Okay, I can give here 2. Okay, I can give here, let's say, color. Okay, I can give a vector also, right? So I can say 4, 8, 12, right? I can give logical value as well, right? So something like this. So this is example of list, right? And of course, if I have to print it on the screen, I can say this. Okay, so see, it has printed. Okay, so one more thing here is the way it is getting printed, right? The way it is getting printed is that it is treating each of these as a different row, right? It is not printing in a single row like vector. Each value is printed in a different row, right? So in a way, you can think it to be like a, you can think it to be like a collection of different data types, right? It's not, so if I give here vector 4, 8, 12, it is printing in the same line. Okay, so vector is a row element. So here, so here you are getting values in a single row, right? Okay, now okay, let's say okay, so let's say what I'll do is here you have how many elements? You have 1, 2, 3, 4, 5. We have 5 elements, right? Now what I'll do here, I will say list, okay, and I will okay, let me give something like this. Okay, name, okay, the list name, and I give, let's say, Sachin. Okay, so I say list name, and I see Sachin, or in fact, let's not do that. Let's do something like roll number. This would make more sense. So roll number, fruit, okay. Let's say color, okay. Let's say marks, and let's say available, something like this. Okay, so I've created a list here. Okay, and what I'll do here is, okay, in this case, I'm going to, okay, since of going list, let me do list 1 here. Okay, so list 1, okay, in fact, okay, and instead of, okay, so this I'll make as a vector, okay, and here I'll say names of. Okay, so what I've done, I have said names of list 1, okay, and I'm assigning a vector. Okay, now if I do print list, I'm going to cut it from here, and let's say I print it here. Okay, now I'm going to run it. Okay, so see this. Did you see any? Did you notice any difference here?
Yes, sir.
Right. So by default, so by default, okay. Okay. So by default, it's not going. Yeah. So by default, you see the row number was 1, 2, 3. It added its own row number by default. Okay. Now by giving names, we are overriding these default column names with the name that we want. Okay. So that's how the names does, and you'll be able to access this using the names. Okay. So if I have to, okay, so let's say if I go here in list 1. Okay, before I assign it to names, I say print list 1 square bracket 3. Okay, and okay, and we'll copy this. And we will put this here. Okay. Okay, so let's do one thing. Let's go line by line. You can see the output how it is changing. Okay, so list done. Now when I say list 3, what did it print? It printed red, because that's what is in the third place, isn't it? Now
Yes, sir.
I will assign it to this. Okay, and now I'm going to say list 1 of 3. Right? So what happens is the inbuilt reference is still there. It did not give error. It did not give error saying that, that third number is not there. So that inbuilt reference is there to the third one. Okay. But you don't have to remember when you give names, you don't have to remember, the reference. Okay. The advantage is I can also say print. Okay. List 1, okay, $sign, and the moment I say $sign, you see it is giving me all these options. And this is what we had used in the exercise that we did, the machine learning exercise that we did a couple of days back, right? So that's how we use dollar. So the list name or data frame name, dollar, column name, or the value name. So in this case, you don't have to remember the reference, whether it is third or fifth. If you know the name, column name, you can, or you can, if you know the name in this case, you can access the particular value. So if I go and run it, you will get same value. Yes?
Yes, sir.
Okay.
Okay. So now let's say I want to change the color from red to green, let's say. Right? So I can say, I'll go here. There. Mouse cursor. Yeah. I come here and I say list 1 of 3. Okay, list 1 of 3 equal to green. Okay, now let's run this and see. Okay, so see, it printed green. Okay, you can even say list of where did I write? Okay, it's okay. Yeah, it's here, right? So I say list 1 $color. Okay, now see, you got this green, right? So you can change the value using your reference, okay, the row reference, or you can use direct value and you can do that. Okay. Okay. So let's say this is our list 1 and I create another list called as list 2. And here I give orange, roll number 1. Let's keep it red because that was, we changed to green, right? Other one. And let's say I make it 5. And I say it's also true. So let me run it. So our list 2 is ready, right? Okay. Now I want to merge list 1 and list 2. Okay. So how do we merge list 1? So I'm going to call it as list 3. Let's want to rename it to list 3. And I'm going to say C of. C just basically means combine. Okay. That's why it's called C. And you can combine that for the vector. When you combine it by default, it becomes vector. Or you can say C here. And I'm going to say here list 1, comma, list 2. Okay. Now when I run it, okay, it ran without any problem. Now I'm going to say print list 3. Okay. So what happened? Okay. What did you notice? So it added the first values till here, right? And it's not showing the reference number, right? The row number. And after that, first list 1 and then list 2, right? Because we said list 1, comma, list 2. The first is list 1, then is list 2, right? And in list 2, okay, value automatically got added to as 6. Since I have not given the name, it took the internal reference or row reference, right? And it continued, okay, afterwards. It didn't start from 1, right? Because we saw that even though 1 is not getting displayed, but internally it manages with that same number, isn't it? Okay.
Yes.
Right. So yeah. So this is how you can merge to list. Now let's say if you want to convert list to vectors, let's say. So we have list 3. Okay. Now what I'll do is I'm going to say list 4. Let's say I call it as list 4 so that we don't lose list 3. Unlist. Unlist is a function and I say list 3. Okay, and now when I run print list 4, okay, so let me run it one by one. Okay, so no error, and I'm going to say print list 4. So you see that when I say unlist, okay, by default it got converted into a vector. Okay, it's easy to convert into vector, right? Because vector is same data type. So if all can convert it into integer, it will convert into integer. If not, then it will convert into string, because string is something which can convert it into any data type and convert it into string. Right? So now you see everything got converted to string. Right? So yes, so these are the things that we generally will learn as part of list. Okay. Now we will talk about another topic. Any questions so far?
No.
Okay. So
No,
now
sir.
great. So now we'll talk about another topic, matrices. What is a matrix? You guys must have done a few years back, right? In the mathematics class. What is a matrix?
Yes.
Yes, sir.
You see, what we have seen vector, where the data is only mentioned in a row. List, data is mentioned in the column. Matrix is two-dimensional. It will have row as well, it has column as well. Okay. So, matrix data type is used to mimic your metrics data that we have in mathematics, right? R is purely for mathematical operations, right? So as once we finish this basics and when we get into advanced concept, we'll see, okay, that it is purely based on mathematics, right? Anything that you can think of in Python, you'll have to probably use a package. Okay, so there are different packages. Okay, the core Python is designed for a programming language, right? So you have NumPy, SciPy, pandas. Those data frames are created so that we can use Python for those analysis. But see, so far we haven't used any packages. Of course, we have package in R2, right? Where the core R itself is available to do a lot of these basic mathematical operations. And for matrices also, we won't be using any extra package, right? But in Python, you have to use NumPy, okay? So of course, the purpose of Python is different and purpose of R is different. Okay. So how do you define a matrix? Of course, just like we define list function for a list, we use matrix X or singular matrix for creating a matrix. Okay, so I'm going to say mat1, something like this. And I'm going to say matrix of, right? So matrix of, okay, now here, of course, we need to give data, right? So let's say I give data here as a vector. So I say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so let's say I have given this data. Now, so if I give you this data and I tell you, plot me a matrix, right? So can you plot me a matrix with this data? Forget about R programming. I just give you the numbers on paper and I say draw a matrix for me on paper. Can you do it?
Yes.
Can you?
Yes, sir.
Yes. So what will you put in the first row?
Like it's 2, 4, 6, something like that. Just 8.
Just tell me, right? What will you put in the
Yes.
first row?
So it will go like 2, 4, 6, and after that it will go like 8, 10, 12.
Right.
Because I think so. One thing is missing here. Two things are missing.
What
If
are
you took
those?
like a 3, 3, then there is a 2 plot are missing. If it is taking a
We
4,
have 10
4, then I
elements
think
here,
so one
right?
plot.
See, the thing is,
Yes.
okay, you cannot draw. You know the numbers, but you cannot draw. You cannot draw because you don't know how many rows and how many columns. You can create
Yes.
10 elements, right? You can create one single row, right, with 10 columns. You can create one column with 10 rows. You can create 2 rows with 5 columns, 5 rows with 2 columns, right? 4 different options are there, right? If I add
Right.
2 more, then you get tons of more options. 1:6, 2:3, no, 2:6, 1:, no, this is 12, right? Sorry. 1:12, 2:6, 3:4, 4:3, 6:2, right? And 12:1, right? So we have 6 different options. So we don't know how many rows and how many columns we need. Okay, so same thing with program. Program will not know how many rows and columns you want to add, right? So what you do here is you say end row. Okay, end row means number of rows. So how many? So I've given, let's say we create 3 rows and 4 columns. 3 rows and 4 columns. When you say 3 rows, so you'll have 3 different lines, correct? And each line will have 4 different values, right? That's what it means. So I'm going to say end row equal to 3 and end col. Okay, end col means number of columns. Okay. So I go and add 4. Now, even this is not enough, right? This is not enough. Why? Because the data should be like, when you say 2, 4, 6, 8, should it be like all the values should be in row or should you put column, right? So let me open the paint and so now we have the data. We know how many rows and how many columns, but we don't know how will this data be plotted, right? Should this data be plotted like this, 2, 4, 6, 8? 2468, okay, or like this 10, okay, or here 2468 down, okay, or like this, okay, we don't know, right? So we have something called as, okay, by row. Okay, so now let's see, let me print it. Mat1. Okay, so let's run this matrix and let's print this metric. Okay, so what happened? What do you see? The value is printed by row or by column?
So column.
By column, right?
Column.
So what it
Column.
has done? So 246 is in the first column, then 8, 10, 12 in second column, right? So if you want to print like this, then by default this by row keyword is false. But let's say I don't want that. So you have something called as by row, and by row is either true or false. I say true. I say true. Okay. Now when I run it, and I run it, so, oh, it. This is the problem with this. I'm going to. I go back here and run it again. Yeah, you see the output here, right? Print mat1 is taking time, right? You see this. So by row, the values are printed. So you see here, it is 246 in first column. But here you see 2468 is in the first row. So that's the importance of by row. Don't give by row is false.
Okay.
Okay, when you don't give by row, it is false. And by row became true if you have something like this. Make sense?
Yes, sir.
Yes.
Great. So now we know how to create, okay, how to create a matrix, okay. But yeah, so you can give more information to it, right? You can give names to the rows, values to the columns, right? So, so here what I'll do is, so let's say I create a variable called column names. Column names variable. Okay, so let's say I gave this as something like match 1, match 2, match 3. So I'm going to say match 1. So this is column names, right? So we have 4 columns. We'll give 4 different values. Match 3. Let's say match 4. Okay. Now here row names, right? We have 3 row and okay, row names, and row I give, let's say I'll give something like, in fact it should have been, okay, that's okay, doesn't matter. Here I give it as own, right, lost, right, and draw. This basically the result. Okay, so I've created this. Okay, I have added the column names, right? Now I want to add this to the matrix. Okay, so I'm going to cut it and paste it here. So we have something called as here, okay, a variable called as dim names. Dim name is dimensions name. Dim names. Okay, dim names. Okay, and dim names, okay, can be different values, right? So it will not be same data types. Okay, so we don't use C, but we use list. We don't use vector, but we use list. So I'm going to say the list of, right? Now you have row. Okay, so first we need to give the row names, right? So you have, okay, we did not run it. That's why it's giving, it's not able to demo. So let's say we run this, Okay, now I come here and I say ROW row names var. Okay, comma, col names var. Okay, so I run it. Oh, what did it say? Row names var not found. Okay, first of all, is this correct? Comma here, right? Div names list of. Okay, so what I'll do is I'll run this again. Let's see. This is the problem. Yeah, that was the problem. Okay, now you see I create print matrix. You see that? See the outcome?
Yes, sir.
Yes.
Right? So this is how you can give names to, okay. I mean, luckily that doesn't look true, right? So instead of match, I should have team 1, team 2, but that's okay. But you understood, right? How to? Hey, 1 second. Right?
Yes, sir.
Okay, sir.
Okay. Now, how do we access the members? Right? So now you see, each of these are called row, right? And each of these are called columns, right? From top to down. So if I have to access this fourth element, so what is the index of this, not fourth element, the value 4. So what do you think would be the index of value 4? So when you had a single row, we call it as 1, 2, 3, 4, right? We said vector of 1, we got first value. Vector of 3, we got third value. Okay, so same thing when we did list of, it gave us that particular row, right? So here, this 4 has 2 values. One is the row number, and what is the column, and second one is the column number. So tell me, what is the row number here, and what is the column number?
So 2, 2. I mean 1, 2.
Okay, row number is what?
Row number is like 2 because it's going like that first and second.
No,
And column number is also 2.
you said earlier was right, but what you're saying now is wrong.
2, 2.
No. 1, 2. So what I'm going to say is 1, 2. What you said is right, but row is 1. Row is not 2. Row is the line.
Right. Yes. Row is 1.
Right? Row is the slipping
Row
line.
is 1.
Right?
Mhm.
So row is
Right.
1. Okay. And column is
Second.
correct. Okay. So if I go here and let's say mat 1, and I say here mat 1 of 1, 2. So row 1, so if I say 1, it is 2, 4, 6, 8. When I say column 2, it is 4, 12, 20. Right? So when I say 1, 2, okay, and when I run it, okay, see, you got 4. So this is how you can access each element. Okay. Now let's say you want to access
Okay.
the elements of first row. Okay, you want to access all the elements of first row. So I'm going to say 1 comma blank. When I say 1 comma blank, you got 2468. You want all the elements of say second column, just leave it blank. When you leave it blank, it will print all the values from that column. Right?
Yes, sir.
Okay.
Understand, sir.
So now let's say I create another matrix of same size, and here let me give it something like this: 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Okay, and I call it as mat2. Right? So this should also work without problem. Yes. So now we have two matrices, 1 and 2. And I'm going to do the sum of mat1 and 2. Mat1 plus mat2. Okay, so what do you get? Taking time? Yeah. Taking time. Yeah. So see, each element got added. Right? Similarly, if I have to print, say, I can say mat2 minus mat1 so that we don't get negative numbers. Or you can do 1 minus, it doesn't matter, right? It is whatever you want to do. So here I'm going to say into, here I'm going to say divide. Okay, so plus is done. Now let's do minus. Okay, then, okay. Now you see, is this matrix multiplication correct?
Into two.
No.
Yes, sir.
Is this correct? You guys have done right matrix multiplication.
Right.
Yes, sir.
Okay, so see here, you have 3 into 2, 6. 6 into
6,
4, 24. 9 into 6,
24.
24. Isn't it?
Yes, sir.
Right? But see, this is not actually how a matrix multiplication, sorry, this is not exactly how matrix multiplication is done. This is called scalar or multiplication, or just you are multiplying numbers. Actual matrix multiplication doesn't work this way. Okay, let me show you how it is done. Matrix multiplication. So if you remember, what we do is we multiply values from row on the matrix which are on the left side into the columns on the right side. Okay. Now, if you see in normal matrix multiplication, your A into B is same as B into A. Okay. But in matrix multiplication, A into B is not same as B into A.
Hi, sir.
Yeah. Okay. We'll continue. So slow to respond. Okay. So we have seen how to multiply two methods. You there, guys?
Yes, sir.
Yes, sir.
Can you see my screen as well?
I can
Yes, sir.
see. Yeah.
Line number 28. Okay, great. So yes, so we have seen how to do matrix multiplication, right? So before doing matrix multiplication,
Right.
first thing that we have to check is the number of rows versus number of columns. Okay, so if you define, let's say, okay, so let's say your matrix 1 is of size A into B. Okay, and your matrix 2 is of size, say, M into N. Okay, M into N. Okay, so let's say this is your size of matrix 2, dimensions of matrix. In R we call it as dimensions, right? So dimensions is Mn and this dimension is A into B. So if I do mat 1 into mat 2, okay, if you're doing mat 1 into mat 2, so it's like saying A into B, right, into M into N, right? So, okay, so this is what we're doing. Order is important here, right? So mat 1 into mat 2 will not be same as mat 2 into mat 1 in matrix multiplication. So if I say 1 into 2, I'm basically saying it is A into B into M into N. So here the internal values B and M should be same. The condition is, will I get? What size of matrix will I get?
4 into
3 into
5.
3. Hello.
Yes. What size of matrix is it? 3 into 3.
3 into 3.
3 into 3.
Okay, so that's what I was saying, that this is not possible. See, condition you see, number of columns is 4 here and number of rows here is 5. This has to be same. Okay, 3 into 4 multiplied by 5 into 3, multiplication is not at all possible. You cannot multiply such matrix. Okay, you cannot multiply such matrix. So here the answer is multiplication. Okay, so when I say multiplication, it's not normal multiplication. Okay, this is matrix multiplication. What we saw was normal multiplication or scalar multiplication. Okay, this is matrix multiplication is not possible. So if I have something like 3 into 4 and 4 into 3, then
It will be 3 into 3.
it will be 3 into 3, correct. Okay, now let's look at our example. What is the size of matrix 1?
Three into 4.
And matrix 2?
It's also
Same. 3 into 4.
It's also 3 into 4, yes. And
Yes.
this is how we multiply. Print mat1 percentage into, sorry, mat1 correct. Percentage into percentage, not simple percentage. Why is coming 8? Okay, percentage into percentage mat2. Okay, so this is how you perform matrix multiplication. If you do into, it is doing simple multiplication. Okay, so what will the answer? What will the size of the matrix?
It will be 3 into 4.
3 into 4.
Yeah, 3 into 4, 3 into 4, 4 and 3 are different. How can you multiply such matrix? See, 3 into 4 and 3 into 4. Can you do it?
No.
You can't. Right. So if I try to run this, let's see what happens. Error. Non-conformable arguments. Okay. It is not possible to do it. Okay. So same thing what I'll do here. I'll say number of rows equal to 4 and number of columns equal to 3. So now what I'm doing is 3 into 4 and 4 into 3. Now what will be the size of the new matrix? Oops. So I have to run mat 2. Do not run. Yeah, it will be 3 into 3. Okay, what happened here? Okay, the dimensions are not the same. So now I go here and I run this. You see, it will be 3 into 3. Okay, so that's how you can perform matrix multiplication. Okay.
Okay. So
3 more important data types which we have done is pending. One is arrays, then factor, right, and the data frame. Shall we continue with array?
okay, sir.
Okay, sir.
Okay, so let's do array and then we will end this session. Okay, so arrays. So what is an array? Do you remember? So array is multi-dimensional. Okay, so vector was one-dimensional in row. List was one-dimensional in columns. Matrix was two-dimensional. Array is more than two-dimensional. 3, 4, 5. You can any dimensions you can create using matrix. Okay, so if I have to create, say, a four-dimensional array, okay, of size 2 into 2 into 2 into 2. How many elements should I input? I'm doing 2 because it's small, right? We can do 3, 4, but then we'll have to have many values. So if I'm doing a four-dimensional of 2 size is 2 dimensions each, how many elements do I need to provide? How many values do I need to provide? If it is 2 into 3, how many elements should we provide?
So it will be like 2 column, I mean 2 row, 3 columns, like that you are asking?
Yes, 2-dimensional matrix. If I say 2 rows and 2 columns, 3
Okay.
columns.
2 rows and 3 columns, right?
Yes.
Okay, so it will be like 6.
2 rows.
It will be like 6, right?
6.
Yeah, because you are multiplying rows and columns. So here, if I need 2 into 2 into 2 into 2, you need 2 into 2, 4 into 2, 8 into 2, 16. So you need 16 elements.
Okay.
So you need 16 elements. Okay. So I need to provide a 16 elements. So if I create array 1, okay, and I need to pass a vector to it, okay. So okay, let's do one thing. Before we create array, let's create a vector because it's a big element, right? So okay, let's create a vector. So I'll say values, okay, and I'll say C of, okay, I can say 1, 2, 3, 4, 5, 6. Then let's say 2, 4, 6, 8, 10. So we have 5 plus 5, right? 2 for 5, 6 plus 3, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so here I'll use array function. Okay, and now I'll pass the value here first, right? So I'll say vals. So this is your value, vals. Okay, now I will pass dimension, dim. Dim, and here this will again be your vector, and you say 2, 2, 2, 2. Okay, and you print you see, so you got these values. Right, you got these values. Right, so see, let me make it big. Okay, so you see, row comma column. See, only 2 dimensions can display on the screen, isn't it? Our screen is 2 dimensions. You can only display 2 dimensions. So what it has done is it has displayed the 2 dimension. Other 2 dimension it is giving you in a different part. So 1, 1, then 2, 1, then 1, 2, and 2, 2. This is your third and fourth dimensions. 1, 2 you can see here. Row comma column you can see. The third and fourth column dimension, not column, the third and fourth dimensions are shown in different. So you can imagine a cuboid, right, with 8 dimensions, and these are the values which are there on each of the faces. You can go into any dimension, right? You can use colon, generate values from whatever 1 to 100 if you want to test, and you can create multi-dimensional. Yeah.
Yes, sir.
Okay.
Okay. So this also has dim names. Okay. But here you have to pass like. Okay. So for example, here you have 4 dimensions, right? So what I'm going to do is I'm going to add dimensions here. Okay. So I'm going to say dim names. Okay, dim names result is list, right? Now the list we need to pass here. So so how many lists should we pass here? 4 individual lists, isn't it? Okay, 1 for dimension 1, for dimension 2, dimension 3, and dimension 4. Each dimension will have 2 values. So what I'm going to do, I'm going to create a list here. Okay, dim1 names, I call it. Okay, so I'm going to say list row 1 comma row 2. Okay, 4 names, right? So this is your 2, this is your 3, this is your 4. So I'll say whole 1, whole 2, I'll say dim 3 1, dim 3 2, dim 4 2, dim 4 1. Okay, now all these I'm going to add them together here. Okay, in fact, in one dimensional, we don't need to create list. List is when you add them, but each dimension will have same data type, isn't it? So here I'm going to say list 1, dim 1 names, comma, dim 2 names, comma, dim 3 names, comma, dim 4, right? Okay, maybe I'm not running. Okay, so let's go and run one by one. Dim 1, dim 2, dim 3, dim 4. Okay, and okay, let's see. Yeah, so you see the number is replaced with the names, right? Very similar to what we did for metrics, right? Or for that matter, even for list, right? Now, if you want a particular element, you will say print arrow 1 of from dimension 1, get me second value, first value, 1 value, right? 1 2 1 1, and you will be able to get it. Okay, these are the 8 values. No? Okay, this is the value, right? Among the 8th value, among the 8 values, this is what we have at 1 2 1 1. Okay, if you want all the values, you leave it blank. You got 3 and 10, right? And you can manipulate, okay, just like you would manipulate any any element. Okay, so that's it about arrays. See, we haven't, so we are just learning these different data types, little more detail. Okay, and so the second part, once we are done all these data types, second part, we will see the applications of these. Okay, we will see the applications, how we actually use these for our real applications. Okay, something like what you showed me the other day on the assignment thing, something similar we'll do when we go ahead.
Awesome.
Okay. If you want, you can talk about factors also today. Let's finish up. It'll not take much time. Factors. So what are factors? Do you remember? So factors, okay, is generally given to values. Okay, so it is a column. Okay, it's based on column, and let's say if column has multiple values. Okay, of course column will have multiple values. There's nothing to suppose. But what I have to suppose here is same set of values are repeating. Right. For example, you talk about say gender, male, female. So male, female will repeat multiple number of times, right? You will, so even though it might have, 10 million records, but the value will not range anything beyond these two values. Okay, so we call them as categorical values in our data analysis term, right, or statistics terms. In statistics, we call them as categorical values. Categorical means those are category, right? If I ask you number of subjects, right? So number of subjects could be 5, 10, 15, 100, whatever. Even if it is 100, same set of values will repeat. So categories. Okay, these are called categories. Okay, so when you fill up a form, okay, it'll ask you, how did you hear about us? So they might give you 10 values: Facebook, LinkedIn, Google. Okay, let's try to write again.